presidents. Today we're going to do a Math.lab where Pasquale is going to solve some exercises for the upcoming exam. As I said, I'm one of two B.Lab's presidents. As an association, we are the largest student union in Bocconi, and we mainly do two types of things. One is representation, and the other one is services to students. By representation, we mean the work we do in the collegial bodies and the work we do in the administration offices where we bring our proposal forward. Instead, by services to students, we mean organizing events, crash courses, and laboratories like the one today, which will be held, as I said, by Pasquale. So, Pasquale, if you want to continue, you can go.
Hi guys, I'm Pasquale, I'm second year BM, and tonight we will just recap some of the main topics for your exam of the day after tomorrow, so Friday. And basically I just summed up some of the main points that you have to fix in order to like pass your exam with a good grade. Of course, it's necessary to have a strong preparation, because as we all know, it's an exam which like requires a lot of preparation, and the most important part is like the ability to do exercises, in my opinion. And that's why with this lab we are going to solve some exercises more than recap. Like we will not recap theoretical question, but we will just like solve some exercises. And so we'll start by basically the lab will be about the two main topics. So first, differential calculus, so derivatives and all that is related to it, and the linear algebra. And I would start as soon as possible to save time for everyone. And so the first exercise we're going to solve tonight is about derivatives. And so we just are going to, let's say, sorry. This first exercise is like it deals with the derivative of a compound function. Okay, is the derivative of the function of a logarithm. So in order to like solve this exercise, we just it's if I succeed to do it, okay. It's basically D. Let me find it. F of x is equal. Sorry. Okay. Should be the setting should be done. And I don't know why my pen is not working, but okay. I don't know why it's not working, but anyway, we will just solve this exercise. So first of all, the derivative of a logarithm function is 1 over the x. So the derivative of ln of x is basically 1 over x. In this case, we have another function inside the logarithm function. So we have to basically understand that it's 1 over 2x minus 1 times the derivative of the function which is inside the logarithm. So which is the derivative of 2x minus 1. And the derivative of 2x minus 1 is 2. So we have to multiply the derivative of the function inside the ln, which is 2, times the derivative of ln of 2x minus 1. So it's 2 times 1 over 2x minus 1. And the right answer for this exercise is the second one, because of course we have to know that it's 1 over 2x minus 1 times 2, which is the right answer. Instead, for the second question, which is the 6.12, we are going to analyze basically the derivative of a function which has more than one variable. So in this case, we consider a compound function which is f of x, y. And we have to calculate the gradient of this function. In order to calculate the gradient of this function, basically we have to calculate the derivative with respect to x and derivative with respect to y. But how can we do in calculating these two derivatives? Basically, we have to consider when calculating the derivative of with respect to x, we have to consider y, that is a constant function. Okay, so we consider for the first term of the function, which is 2y e of x, or e of x, to the power of x. We have to consider to calculate the derivative, so the gradient with respect to x. We have to consider y as a fixed value, and so the derivative of 2y(x) will simply be 2y(x), because 2y is a simple the constant, and e to the power of x, the derivative of this function is e to the power of x, and so we keep this value, this term. Instead, for the second term, we have to consider, as I said before, we have to consider y as a constant, and instead x as the variable. So basically, the result in order to calculate that function would be simply 2y e of x will become 2y e of x plus xy. Just we have to consider that the derivative of a function which has only one variable is simply y. So the first, the gradient for the x term is 2y e of x plus y. And so only in the first option, so in the A option, we have this part of the gradient. But then we have also to consider the second, in order to be sure that it's the right answer, the first answer, even though we can already say that it's either the A or the D, because it contains the what we have just calculated. And instead, for the second derivative, so for the derivative with respect to y, what happens it's the same. So we have to consider that y e of x will be the fixed term. Instead, y is the variable. So we just put 2y is 2y e of x is the term, and so simply it becomes derivative 2 e of x plus the derivative of xy with respect to y, but the derivative of xy with respect to y, it's simply x, because of course it's as saying, let's say, if we want to calculate the derivative of 3x, it's simply 3. So we have to consider this y simply as a tree, as a number, as a constant number, without making any further computation. And we simply would understand that the derivative of this term would be simply x. And so we will understand that the derivative of all the function, all the two variables function will be, of course, the first one, so the option A. And this exercise, in fact, as this as the final and the right answer, because of course, this has the gradient with respect to x, which is the one we calculated before, but also the gradient with respect to y, which is of course the one we just calculated here. And so we also revise, let's say, the part about the two variables function. So for the derivatives for this kind of function, but of course we would need also to revise something else. And let's say in this case we have another exercise about the differentiability of a function. And specifically in that case, we have to calculate the tangent line of a function, okay? But how can we do to calculate the tangent line of a function? It's not that difficult because we know actually that the derivative of a function is always also equal to the tangent of that of the point in that of the function in that specific point. So we can say that by calculating the derivative of the function in that point, so in x0, which is equal in that exercise to 1, what will we have? Basically, we have to calculate the derivative in order to calculate the m, so the angular coefficient of the straight line. And in that way, we can simply understand how to calculate the line itself. So first of all, we would like to know how to calculate the derivative of that function, which is actually x squared times e of minus x. Normally, before calculating the derivatives of a function of any function we face in an exercise, we just have to see if that function is a function that we can actually like understand how to compute because of some formula or because of whatever exists inside the calculation, inside our knowledge. So inside the formula we have studied or whatever we have studied before. But in that case, it's basically impossible to understand how to do it without using using a simple linear formula for the calculation of derivatives. So basically, what is left to do is to calculate the derivative of a product of function, and we have a specific formula for calculating the derivative of a product of functions. And this formula for calculating the actual derivative of a product of function is equal to is equal to f prime times g, where f is the first function. So in our case, it's x squared, while g in our case is e to the power of minus x. So in order to calculate the derivative of a product of function, we just have to calculate f prime times g plus g times f, g prime times f. I would like to write, but I apparently have not this option according to my iPad. But oh, maybe now. Oh. No, it doesn't work, but it's okay. Just we have to calculate the derivative of that function. So first of all, we calculate f prime, which is equal to the derivative of x squared. And as we all know, the derivative of x squared is equal to 2x, okay? And then we multiply 2x times e to the power of minus x. Then we have to add the other function, which is instead equal to g prime times f of x. So it's x squared times e to the power of minus x times the derivative of the function which is inside the power of minus x, which here is of course minus x. So in order to calculate that function, we just have to calculate the derivative of minus x, which is -1. Oh, it's working, maybe. And so we have said that the derivative of that function would be equal to 2x times e of minus x plus x squared times e of minus x times -1. And here we have to actually just substitute the value we were given inside the result to calculate the value in that point. So if we want to calculate f prime of x0, basically it's equal to 2x times e of minus x, as we said, plus -1 x squared times e of minus x. Okay, and so substituting this value here, we will obtain simply that the result would be 2 times 1 times e of minus x minus x squared is equal to 1, e of minus x is e of minus x in order to calculate that derivative. So we can put e of minus x as the denominator. So it's ex here, and up we will have just 2 minus 1. If we substitute also the 1 here, the result will be here. So instead of the x, we substitute the 1, which is the one which is given by the exercise. We will have understand it here. We'll have 1 over e, and this is like this 1 over e simply works as the coefficient of the straight line, because as we all know, the coefficient of the straight line, so the angular coefficient of the straight line for the tangent line is equal to the derivative in that point. But now we have also to understand which is the value we have to calculate. So if we want to calculate y0, it's simply equal to the value x0, which has to be inserted inside the function. So we just put 1 inside the f of x function, and so it's equal to 1 times e to minus 1. So also here we have that is equal to 1 over e. As we all know, the formula to calculate a straight line is, I will change color. It's y minus y0 equal to f prime of x0 times x minus x0, which is equal to, so x minus x0 is this one, so 1 minus 1 over e equal to f prime of x0, which is 1 over e, and x0 instead is 1, so it's x minus 1. And so now to understand the formula for calculating the line, it's basically y equal to 1 over e x minus 1 over e, because it's 1 over e times -1, and plus 1 over e. So we can delete these terms since they are equal by opposite, and we are left with the equation of the line, of the tangent line of that specific function, which is exactly as equal as the first option we have. So the option A, which is y equal to 1 over e times x. And that's okay for also for this exercise. If you have, of course, any questions, you can ask me whatever you want because I'm available for everything. But it should be straightforward because we just like recapping just a little bit. We first of all calculated the derivative in that point, and so it's basically 1/e. Then we calculated y0, and then we use the formula to calculate the result, to calculate the straight line, which needs, of course, apart from x0, which already was provided by the exercise, also f prime x0 and y0. We have all these we had all these points calculated, and so we could calculate the formula for the tangent line, sorry. And so there's all about also how to calculate the classification. Then another exercise about the differentiability and about in general the derivatives is this one. So we know that variable is twice differentiable, okay? But what do we mean by twice differentiable? By twice differentiable, we just mean that in a neighborhood of x equal to 0, it could be that we can find the derivatives of the function in that neighborhood, okay? And in order to understand how to deal with this exercise, we just have to understand that we have 3 points provided here, which are f of 0, which is equal to 3, f prime of 0, which is equal to 0, and f second of 0, which is equal to 2. But what is the difference between the 3 information provided here? The difference is that the first is just the function, and like f of 0 equal to 3 is just the function in that point. So in point x equal to 0, the function takes point in y equal to 3. Instead, with respect to the derivative, the first derivative of the function in point x equal to 0, the derivative of that function is equal to 0. And instead, the second derivative of the function is equal to 2 in always about that like that point, always the same point, and the result is 2. Now, what can we say about these 3 points that we have been given in this exercise? First of all, we know that by knowing the derivatives and specifically the signs of the derivatives, we can understand how is the function. Okay, so with respect to the first derivative, we can understand that if f prime is greater than 0, the function is positive, while if f prime is less than 0, is increasing. If f prime is less than 0, the function is decreasing. But in that case, we have f prime of 0, so f prime of x, which is exactly equal to 0. So we just don't have any information about, let's say, if the function is increasing or if it is decreasing. But the second derivative actually gives us information about the function, okay? Because basically what adds to our knowledge this information? This information just says us that the function, because we know that the function can have concavity, up concavity or low concavity. So concavity towards the up or concavity towards down. And this is seeable thanks to the second derivative. So if the second derivative is greater than 0, we have that the function is concave. Instead, if it has a derivative which is less than 0, the function is convex. Okay, and so here we can understand that in the point x equal to 0, the function assumes a positive value. Like the second derivative. If the second derivative assumes a positive values, then the function is concave in that point. And if the function is concave in that point, it can only mean that in this case, the 0 for the function could it be a local maximizer if the function is concave? No, it can't. A global maximizer? No, because it can't be a maximizer at all. A local extremum? No. So the only option left, which is also the option we had talked about before, is the fourth option, and so is that 0 is a local minimizer, and so like 0 is the local minimizer for the function in that specific point. And that's like this is about the exercise we have prepared about about the differentiability and about let's say how functions behave in the world of differentiable calculus. If you have other questions about this first part, of course you can ask, and also about the exercises we have just solved, because of course any doubt is acceptable. Instead, if you don't have any further question about this first part, I would move to the second part of the evening, let's say together, which is the second part is about matrices and about all the linear algebra. So here we just have a matrix, okay, and we want to calculate the rank of this matrix or the determinant of that matrix, because of course this is what the exercise is asking to us. Okay, but what do we know about the rank? What is the rank actually? The rank is the number of rows or number of columns of the largest square, matrix n times n. So the squared matrix, not this one, because this is not a square matrix, but this is a rectangular matrix. We have to find the largest n times n sub matrix of A, so the matrix we are provided with a non-zero determinant. Okay, so we have also to find the determinant of that matrix in order to understand if it's worthy or not to calculate the rank. Which are like we have these metrics, okay. Sorry, it's just going up and down, and we have that. Let's say A is equal to 1, 1, 2, 2, 3, 4. Okay. Determinants we can calculate are not that much actually, because we have either these, which is square sum matrix, or like is the red one, either the yellow one or the red one, in order to calculate which is the best matrix, which is the best, which is the determinant, which can give us the value for the norm, for the rank. And here we can understand that for the yellow one, we can calculate a determinant which is basically equal to 2 minus 2, because it's 1 times 2 minus 1 times 2, and so it's equal to 0. And so we cannot understand the rank of the matrix only by seeing these kind of determinants, because it's not worthy. Instead, for the second one, so for the red one, the determinant is basically equal to 8 minus 3 times 2, which is equal to 6. So the determinant is equal to 2. So it's a non-zero determinant. So since we have understood that the determinant is equal to 2, so it's a non-zero determinant, we can say that the rank of the matrix, like of A, is equal to 2. Why it is equal? And so the right answer is the second one, is the B. But why can we say that it is so? We can say that it is so because we have just said that the rank is we have just to see that the rank is the number of rows or column of the largest submatrix square submatrix of A. This is the largest square submatrix of A, and n, so the number here or the number here, is equal to 2. So also the rank is equal to 2. And that's how we solve this kind of exercises, nothing more than this. And we can move on to the following exercise. So basically we just are solving, also in this case, an exercise which requires us to talk about with respect to matrices, okay? And in order to solve this exercise, actually, we should know a little bit of theory, because here, like the formula are just formula that we have to know prior to the exam. We have to study. So let's say A, as we know, the formula. So the formula, which is A B to the power of -1, which is the right formula for calculating this matrix, because it's the product of two matrices, because A is the first matrix, B is the second matrix, and we have to calculate how we can either write these kind of matrices, the inverse product of these matrices. In order to calculate the inverse product of these matrices, we can basically write that, like according to the theorem we have studied, it's B to the power of -1 times A to the power of -1. And so this is literally what is said by the theorem. So it's how it's a formula we have to know. And so the right answer for this exercise is the first one, is the A. The right answer is the A. But what we can say else than that? We can also say that, for example, analyzing the other options, we will see that, of course, the thing we have to calculate always is this, okay? And does not exist, not at all, because of course we know that it exists since, of course, we have studied it. But the second one cannot be the right option, because we know that the order, it's not like A to the power of -1 times B to the power of -1 is not equal to B to the power of -1 times A to the power of -1. Even though normally in whatever operation we are going to do in algebra or in mathematics, whatever, in statistics, whatever, this would be a normal option. But here we have to consider that these A or B are not just numbers or function or whatever. They are matrices, and so matrices work in a different way. They don't work as the functions or the numbers or whatever. They work in a different way, and so it's necessary to learn this property of the inverse product of matrices. And that's everything about also this exercise. And we now move on to this other exercise. Sorry. Okay. So the 7.9. Okay. And how can we talk about this exercise? Basically, this exercise just says that there are two n times n matrices with n greater or equal to 2, and the determinant of A, which is equal to 3, and B is equal to 2A, okay? So basically we have information about A, but we have a linear correlation about B and A, okay? So if we want to just analyze how these work, let's say, let's open another here. No, it's not this one. It's before. Is this one? And if we actually want to analyze how this works, we have to consider that. We have to consider a formula actually that we studied before, because it's not that easy to process, like to understand how to understand how this works. Because if we don't have the prior knowledge about the formula we can use in that specific situation, we will have a little bit of difficulty in analyzing these results. Why we have this like difficulty analyzing these results? Because of course the important part about this exercise is always to consider like that the formula about the determinants. Okay, the formula about the determinants is not that difficult, because the formula about determinants just tells us about how determinants work, and it's that the determinant of k times, for example, whatever matrix M or A, or however we want to call it, let's say M, or yeah, it's equal to k to the power of n times determinant of M. Okay, so what can we say about it? We can just say that here we know that A and B are these two matrices, and the determinant of A, so the determinant of A, which in this case would be M, is known. Okay, but we also know that B is 2A. So the determinant of B, this will be B, will be equal to the determinant of 2A. Okay, are you following me? Which is equal to k to the power of n. So k in this case would be 2 to the power of n, and we don't know n, so we just leave n, times the determinant of n. The determinant of n is the determinant of A, which is given in our data, and the determinant of A is equal to 3. So we just write 3 instead of the determinant of M in a general formula, and we understand that the determinant of 2A, which is the determinant of B, is 2n times 3. Okay, we cannot go further because, of course, we don't have any information about the actual results of n, so we don't know n. But what can we say? We know that n, like the matrices are matrices n times n. Okay, so we just know that n is also greater than or equal than 2. So like the only possible choice in our like among our results, among our like answers, which are here, we have 6, 3, 12, or 36. But if we want to analyze these like these results, 2 to the power of n, 3 times 2 to the power of n, can it be equal to 6? It will be equal to 6 if and only if n is equal to 1. But n has to be always greater than or equal than 2. So the first choice is not possible, and so A, no, cannot be considered. The second one is 3, always 3 times 2 to the power of n is 3, B. But in order to be 3, n should be equal to 0. because it's 3 times 2 to the power of 0, which is 3 times 2 times the power of 0, which is 3, and so it's b. But always for n that has to be greater than or equal than 2, it cannot be possible that the function assumes that values. So it cannot be that n is equal to 0, because it's not a value that is greater than or equal to 2. So both a and b are not possible. The third one, so c, is 3 times 2 to the power of n, and has to be equal to 12. In this case, it's 4 times 3, which is equal to 12, so n has to be equal to 2. It's possible, this choice, because of course, like, we have that n has to be greater than or equal than 2. So C can be possible. We leave it here. We don't have the certainty that is the right answer, but we have just a possibility, okay? And then we have the last one. So 3 times 2 to the power of n, which is like 36. But how can be equal to 36? Because we know that 36, like, divided by 3, so this 3, is equal to 12. But like 2 to the power of n, can it be equal to 12 if n is a natural number? No, it's impossible, because of course 2 to the power of 0 is 2. 2 to the power of 1 is 2, like it's 0. Like 2 to the power of 0 is 1. 2 to the power of 1 is 2. To the power of 2 is 4. To the power of 3 is 8. And to the power of 4 is 16. So we don't have any 12 values. And so we also, the D option is not possible. So since we have like analyzed all the possible options, we just go for the third one, because it's the only possible option. It's not like the certain option. It's not the option we are sure to have inside this kind of exercise. But like, since we have only these 4 possibilities, we basically analyze which is the most probable to happen, and so the C1 is possible. And then we can move to the final exercise for tonight, which always takes into consideration the matrices and the linear algebra. But what can we say about this exercise? About this exercise, we can just say that we consider a matrix which is 3 times, like n times n, of course, matrix. So it's a square matrix. And it's a 3 times 3, because of course we have that the number of numbers in the matrix are 3 and 3, 3 like horizontally and 3 vertically. Now we want to calculate the determinant of A. But how can we calculate the determinant of A? It's not that difficult, because actually it's just that we have to use a view that we like studied. Maybe some of you also studied it in high school. It's a well-known rule. It's the Sarus rule. Maybe in, like, I don't know if in your classes the professors have called this rule Sarus rule, but basically it's the same for every classes. So we have just to understand that we, first of all, we rewrite the matrix. So A, which is equal to 2, 0, 3, 1, 2, 0, 3, minus 1, minus 1. And then we add, in order to use this formula and to use this rule, we just have to recopy the first 2 lines here. So 2, 0, 3, 1, 2, 0. Now we have to understand this, to understand how this formula actually works, okay? And let's say, how can it work? It can just like, look, we highlight the diagonals of the our matrix. Okay, so the first diagonal, the second diagonal, the third diagonal, and then the other verses. So this other diagonal, let's say this other diagonal, and last but not the least, the third diagonal here. And here we can use this formula to understand how it works, because here to calculate the result, we just have to basically see that determinant of A is equal to this first line, which is the green line. So we basically understand, like we are doing something very, very straightforward, because it's just the application of the rule. And so it's -4, because it's the product of all these numbers. We have to do the products of the numbers in the diagonal. So it's -4, then -3, because it's the product of these other diagonal, and then minus, not plus, like 0, because it's 3 times 0 times 0. And then we have to do minus the values in the other direction. Okay, so this, and this diagonal. So it's basically minus, it's 3 times 2 times 3, so it's minus 18. Minus, we have 2 times -1 times 0, which is 0. And then we have 1, 0, and -1, which is -0. Okay. So here we just move, and we have a 0 here, a 0 here, a 0 here, and we do -7, like -18, if we want to group like this one and this one. This for the first, like this one is the first, and is the second. Like this is with doing the first verse, is doing the second verse. We add up, and we obtain -25. So, understanding our actual results in the numbers, in the possibilities we have here, is just A, B, C, or D, but according to our calculation, the right answer is the A answer. And so, because the determinant of A is equal to, no, it's -25, so it's B. Sorry. And so it's B, and the determinant of A is -25. Simply doing the formula, nothing more than the formula. This is how this kind of exercises work. Like we have just to focus on what is the request of the exercise, what they ask to us, what they want from our calculations, like nothing more than it. Because like this kind of exercises, so the multiple questions exercise, or basically the one which requires us to know formulas, and which requires us to know, let's say, the basic assumption of the exercises and of all the topics we have studied, just requires us to know this formula and to know how to apply this formula. So my suggestion for you is to do as many exercises as possible, and to like see the reasoning that is behind the exercise, because of course this is the most important part of let's say doing this kind of thing. So these like I'm available for any questions now, both now and also in the future. If you want to ask me whatever today or tomorrow before the exam, it's like you can ask me whatever, and I'm available for everything also now. But the only suggestions, like the last suggestions I want to give you, like just be relaxed during the exam. Don't be too anxious, because of course being too anxious will like give you so much stress during the exam, and so it's worse. And just be like, not, I won't say relaxed, because it's kind of impossible to be relaxed, but just try to do everything like with the things we have studied before. That will be easier for sure. Thank you for listening.
So goodbye.